Okay, we're at the Computer History Museum in Mountain View, California. It's April the 3rd, 2013, and we're here to interview and gather oral history from Lucio Lanza, who has a tremendous experience in electronics in a wide variety of areas, and our goal is to capture that history and add it to our archives. So Lucio, welcome. Thank you for joining us.
Thank you for inviting me.
This is Doug Fairbairn, and I'll be doing the interviewing. So Lucio, our first step in these oral histories is to go back to the beginning. You know, where were you born? What kind of family environment did you grow up in? And how, if you can identify, did that sort of lead you towards a career in technology?
Well, that's going back a few years. So I was born in 1944 in Italy, in a little town in the province, so in the County of Milan, in Lombardia. I was in this little town because 1944 was Second World War, and we were what is known escape from the towns, because the towns were kind of under attack. You have to think in 1944 was when the fascism was collapsing, but in the north was still fascism, and the Italians/Germans did not have radars and did not even have very strong weapons against the planes. So routinely at night the cities would be bombed on the civilians, according to the Patton philosophy that the best way to discourage combatants is to kill their parents, which is good philosophy. And so I was born there in 44 in a very small village. I went back there to see it, and the village is probably 50 houses.
Very small.
And one villa. The villa is Villa Litta, the village is called Orio Litta. And interesting. And I was the fifth of 5 kids from the second marriage of my father, first marriage of my mom. His first wife died. And so I had another half brothers from there. So 6 of us. The 5 of us, close brothers, and one sister, were within 7 years, 7.5 years.
Oh my, your mother was very busy.
So we were pretty close. That tells you that we were extremely close. So being the youngest was clearly somehow being considered very precious by all the other ones, and also I could learn a lot from their experiences. So after the end of the war, we went on the Como Lake. We stayed there for a little while. My father was in what is called in Italian the Guardia di Finanza, or the financial police. The financial police is at the same time. And we were living in the headquarters of the police, the so-called police stations. And it was a safe place to be, and a place where you would always be encouraged to stay in line. And it wasn't easy. It was just being military, just nothing you can do in a wrong way. And then once you are in this kind of position, you get transferred wherever they want you to go. So my father was transferred in the south close to Bari, by the way, close to where he was originally from. He and my mom was originally from.
Close to where was it?
Bari, B-A-R-I, is right facing Greece.
Okay.
The Lanza name is, if you go back 220 years, is a Sicilian name. From Sicily went to Naples, from Naples to area around Naples, and from that area to Bari, and from Bari to north. And I tracked it back to close to Palermo. There's a lot of Lanzas there. Lanza, in fact, comes from lance. So it's Lancia. The car is the same. So anyway, we moved down there for a few years, and then when I was 12 years old, in 1956, we moved from the south back to Milan. And so I had the elementary school and the first time of middle school there, and I had most of the high school, all the high school up north in Milan. Now, interesting, it may be interesting, well, my mother was just the mother of 5 kids plus 1, and she died 4 years ago at the tender age of 95. She disappointed me because I told her I wanted her to beat my grandma that died at 101. She didn't do it. But in fact, she died.
You have some long-lived genes in your family.
Yeah, my dad died in 94. So it's so interesting. My high school was mainly all in Milan. Now, the interesting thing about my high school is that it was not a scientific or technical high school. It was what the Italian calls classical high school. So my background from education until I was 18 was fundamentally the classical high school. So I studied Latin for 8 years, Greek for 5 years, French for 5 years, history for 8 years, philosophy for 3 years, math for a long time, but
sounds like Alberto San Giovanni.
Very similar.
Yeah, very strong classical background.
The reason is that the classical school was considered a tougher school, and you were considered having a general better education. And when I finished high school, I don't give you this because it's everybody, my family thought I was going to get into medical school because my father wanted me to get into medical school. My older brother was an engineer. The other 2 were lawyers, went to law school, and my sister went to teaching and just teaching in languages. And
so they all went to university? And,
they all went to college.
This is because your parents felt that was very important? Or
it was absolutely important. It was fundamental. There was no choice. You go to college. Now, don't put it in writing, but they could not afford it. So the way to go to college is that you bust your ass and there is no taxes to be paid because you're on top of your classes. And so when we moved from the south to the north, of the 5 kids that were very active in school, 4 had top ranking in Italy, which was used against us because when we went to the schools in the north, since we were from the south, and there is the closest thing you can think of racism between the north and the south, closest you can think of. They thought that couldn't be possible that 4 of us were good, so they really treated us like crap for the first couple of years until we demonstrated we were okay. So I went through school, and when I finished the high school, it was interesting because my father thought I was going to do medical school. The teachers in the high school were absolutely positive I was going to do philosophy. Positive. Because I was very active in philosophy, very active. I mean, the teacher would give me, on any philosophy, Italy was teaching those time every discipline under the Gentile, is a philosopher, philosophy, that was teaching every topic historically. You will not learn philosophy, you will learn history of philosophy. You will not learn art, but history of art. Because there was a concept that if it's the history, you're going to see something versus just picking things in an arbitrary way. So when I finished high school and I declared I was going to do engineering, I remember my philosophy teacher crying. So I'm going to go to the Polytechnic of Milan.
So where did you get that idea? Had you done any?
I never realized what. I think I had and I have a lot of admiration for my first brother, Aldo, that was doing engineering. He wasn't doing extremely well, was doing engineering. And he always was the best in high school, always doing extremely well. engineering, he had tough time, and Polytechnic of Milan was a tough place. He had to work while studying, and I thought that engineering was something like using philosophy to the immediate benefit of people. That is, you understand something, you see better than others, and you get it out before anybody else does. Mm-hmm. So I ended up, and I was doing extremely well in math. The difference, I was studying like crazy philosophy, and I was doing math just intuitively, absolutely intuitively. I had the math teacher that was so annoyed at the fact that I would always find a mistake in what she was saying that sometimes she would call me and say, "You talk." And I wasn't bashful about telling him that's not right. if you do n minus 1, 2n minus 1, yeah, it is odd, but you cannot do it because everything is considered 2n plus 1, which is start from 0. I remember that one. She reminded me that when I was graduating. And so I went to Polytechnic of Milan. Mm-hmm. And Polytechnic of Milan was a tough school. When people tell me about college here, they say, "Oh, the life in college, oh, that's a great time." Was the toughest time of my life. Polytechnic of Milan, the curriculum to get a doctor in engineering was 5 years. 5 years was the minimum, which was a very interesting way of doing it. It was 5 years, and you had 31 classes and topics. In the first 2 years, we had 11. Unless you passed the top 9 of those 11, you would be blocked. Mm-hmm. So, and you could not take any classes until you finished those 11. It was called a deadbolt and a catenaccio. Unless you pass those, you are not going to proceed. And there were 1,200 people in the class entering the Polytechnic of Milan in 1962. Of the 1,200, 2 women. Of the 1,200, normally what would happen is that 40% would not pass the 2 years. Then you had a maximum of, I think was 35, I might be wrong, it can be 50 or 35, that could go into electronics. And the other could just spread around in civil engineering, mechanical, electrotechnic, and so on. Between 35 and 50, I don't remember the exact number. They had the 50th year reunion last year, and I think 28 people participated, so probably it was 35.
Out of the 35?
Yeah, mm-hmm. Yeah. Well, a couple died, and I couldn't go. So I think 35. So in order to get there, you had to have 9 out of 10 as grades. So it was tough. Mm-hmm. And the reason why they would do that is there was not enough equipment. Mm. So you cannot do anything hands-on if you throw 500 people in. Today they throw 500, a few years ago they threw 500 people. That's ridiculous. You just don't get any understanding. And so I was lucky enough to get into that. I went to school. Polytechnic of Milan at the time was...
So was this, were you studying transistor-based stuff?
No, it's very interesting. The first 2 years are math. Mm-hmm. Math, physics. It could be a physics, it's absolutely theoretical stuff. There are only 2 applied things, that is machine designs, and only 2 classes were application. On the 3rd year, you decide which direction to take. If you take electronics, electrotechnical, you are allowed to go into electronics if your degrees are high, if your scores are high, if your card is high. Otherwise, you just spread around. Mm-hmm. And the philosophy was that you would get a degree, and that degree would allow you to be an engineer in any discipline. In Italy, today, I could sign up for a building, or for a bridge, or for a car, for anything. Because what you are doing is studying general engineering. So I studied science of construction, which is buildings. I studied mechanical. I studied how to do bridges. I studied all the stuff, very, very broad. And then the third year you do that, and then the fourth year you start specializing if you are lucky enough to get into electronics. And the electronics it becomes electronics, or more system and transistor, but also transistors later on, and robotics. Those were the machine control was called robotics. So that was the two directions you would take. And then you get more and more into more electronics, and the degree I ended up getting was no computers degree. It was a computers class from Grasselli. They got also some degree at Stanford for 1 year or so. He taught computer science, was the only one that had a test that was a yes/no test, and there's multiple choices. The only one. Everything else was a test one-on-one, 1 hour, and the teacher is going to ask everything he wants. So that was the test. It wasn't very easy to go through. And so fourth and fifth year were real electronics. And so one class in computer science, a lot of classes in communication. My degree is on satellites, communication, electronic communication satellites. And so I've done more Maxwell equations than anything else. So that's and the computer science was called computer science. I never thought it was a science. It was just stuff. No, not very complicated. And
another language.
Yeah, no, not so. That wasn't very. So but Polytechnic was the classes were this way. You go at 8 o'clock, 8 to 12. You have 4 hours of theoretical class, teacher teaching, and you're taking notes, and you're gonna and then 4 hours of what's called esercitazioni or exercises, and that is practice. So tests and the real life building things in any fashion. Build mechanical stuff, you build electrical stuff, you build all kind of hydraulic stuff, all kind of stuff, all hands on. So 4 hours that way, and 8 to 12, and 2 to 6 you would do the other ones, plus 4 hours on Saturday. And this one would go from October 1st till end of May. And the last week of May would be tests. So you have to study for the tests and the exams before that in this thing. And since I had no money, I would work. So I would teach pupils math and so on in high school. So when I finish at 6, I would go and teach from 6 to 10, 10:30, and then go home, eat, and go to bed. If there was classes, if I had an examination to do, study, and then go to bed if there was time. So that was my 5 years of Polytechnic. The thing I'm proud of, I ended up exactly in 5 years. And I was one of the 11 people to finish in 5 years. So that was...
Out of 1,200 who started.
Yeah. 11 in electronics. There was other, but in the electronics of the 35 that we had, I think 11 ended up in 5 years. It's and I was not the youngest. Another guy was younger. And my father threw me to school at 5 years old, so I ended up, I was barely 18. So that's, I did 22, 23, 18. Yeah, I was just barely 23, 16. Yeah.
So then what?
Then what happened is that I was lucky because the work environment was very good economy. Italy was moving up very powerfully. I mean, people were really driven. And so I applied to various companies to see whether they were interested. And being in that position at the Polytechnic of Milan, I had more than 30 job offers. I had job offers from everybody. And
now these were all within Italy?
All within Italy, and in fact, all close to Milan. Okay. The philosophy is normally that you take a job and you stay home in those days. So you don't leave home until you get married. Or you have to go to work out of town, and my family liked better if we stayed there. I have no reason to leave. And besides, you need to help the family, so you stay in. You don't leave. It's so your salary comes in, and you can do something better for everybody. And I remember I accepted a job from a company. It was a subsidiary of Pirelli, because it was 10,000 liras, which was higher than the job I was offered at Olivetti. 10,000 lira salary was about $10 difference.
$10 per
month.
Per month?
Difference.
$10 per month?
So anyway, I accepted the other one. And I went there and I accepted it. My brothers were not very happy accepting that. I said, well, it's good, we need the money. And I went there and they were happy, very happy. And they told me, well, you need just to go make a medical visit and you're in. So I went to go to get a medical visit and the doctor said, okay, so, wow. You have a very good CV from school. Wow. Yeah, and I study. I said, what are you doing here? The doctor. I said, well, I accepted the job. I said, is that the only offer you had? I said, no. What are you doing here? I'm going to start the job in a week. No, you're not. I said, you have a choice. I'll make you fail the medical test, or you refuse the job on your own. And he said, if you fail the medical test, of course, I have to put that on your resume.
Record, yeah.
And your record. Your call. So I went home. I talked to my brother, and he said, so you called him and you said that you decided differently. I said, no, but I told him I would go. I cannot do that. Well, you call him and you tell him you decided differently. I cannot do that. Well, you call him, okay. So I called him. So the other company that had the offer was Olivetti General Electric. Mm-hmm. It used to be Olivetti, but GE had just bought 80% of the interest in the Olivetti computers. And the Olivetti mechanical stayed, but the Olivetti computers, which had very nice machines, the 115 was the first one, and that's some LAS, very nice machines, very nice. Of course, for transistors mainly, went to the General Electric. So I accepted the position in General Electric, Olivetti General Electric, because it was Olivetti and I wanted to do computers. Mm-hmm. Most of the other people went to work for telecommunication company, GTE or Siemens or others. I really like computers, so I probably was the only one of Polytechnic of Milan of that year. I was the only one, and they went to computers in Olivetti General Electric. And sure enough, I really liked it. I'll give you this story because that gives you a little color about me. I accepted the job, and then the starting time was in 4 weeks. I accepted the job from Mr. Kasabji, a great Egyptian engineer. I really respect him, very smart. And they got me the job. I went there, and I said, oh, well, great, I'm in. And they said, okay, great, you're going to be working for Mr. somebody else. I said, no, I came here to work for Dr. Kasabji. No, Dr. Lanza, you work for Dr. Vincent. No. And they said, in fact, no, you're going to work for Dr. Belperio. Dr. Belperio. I said, okay. So they gave me a desk in a room like this, 12 desks. I got a desk there. And Dr. Belperio calls and says, okay, Dr. Lanza, Engineer Lanza, that's what we call him. Engineer Lanza, come here, let's talk. And I started talking, and he said, well, I want you to look at this circuits because we seem to have some problems there. Look at this circuit here. Can you say something about this? I looked at it and I said, you probably have a problem on this inductor. They said, yeah, I thought the same thing. I thought there may be some magnetism.
Some what?
Magnetism. I looked at the guy. Say again. I thought there might be some magnetism. So I left, and I called the head of personnel, the head of HR, and I left a message with the assistant, Dr. Sabji, and I said, I am not going to work for this guy, not even dead. They said, well, you are in his office. That's it. Oh, I can fix that. So I picked up my desk. And I moved the desk in the office of another executive, the lab of another executive. Then I went to see him. I said, Dr. Vinsani, I'm going to work for you. I said, no, you're working for me. No, I'm going to work for you. I'm going to work for the guy. I cannot do that. So, well, let me talk to Mr. Kassab. So he called, they said, okay, you're going to work here. So that's how I got my first job. And then they asked me to, the first job, they said, well, Dr. Kassabji has an idea that he would like you to work on. And we at GE have decided that, OJ, we decided that we really would like to connect computers serially, because these cables are crazy. We would like to do a serial interface. So can you see if you can conceive a serial interface for these things? Sure. So I started looking at that, I started designing, and a product had just come out from Fairchild. It was the 9300 4-bit shift register. And I thought it was a great little product. It was a TTL. Mm-hmm. So I designed the TTL for the interface with an MSI was the equivalent of 50 transistors, I think, or 80 transistors. Mm-hmm. 4-bit shift register. And
this is late 60s?
This is now 68. 68, exactly. And I started February 21st, 68, so this was 68. 68, and so I really liked it, and I designed the thing, and what happened is that there was a lot of stuff that was pretty original. So we applied for a patent. That's another story you love. We applied for a patent and said, well, great. Now at GE, they had, I was very happy, and I really liked the fact that I was in something extremely advanced, and I was talking to people, very selected people, because this was one of the most secret projects, because IBM didn't have one. Mm-hmm. IBM was going on modems. And we thought it was a secret project. So I was the only one doing it. I was very excited about it. I had some circuit engineers with me. Mm-hmm. So we were applying for patents all over. So I was writing patents. I didn't speak any English, but I would write them in Italian, and I would check in English just to learn some English if I could. I studied French. 90% of people would study French in those days. And then I asked to look at some other papers, and that I really thought were important inside GE or Olivetti General Electric. And they said, no, you're not allowed to look at those, because those are secrecy level 4, and you are only allowed to secrecy level 3. And I said, really? Yeah, you cannot read those.
These are internal papers?
Internal papers. So that's secrecy level 4. Well, okay. So they said, okay, just if you can finish the stuff on the patents. I said, I'm sorry, I cannot do it. Well, you cannot do it. They are secrecy level 4. I cannot read it. I cannot check what I'm writing. So they moved me to secrecy level 4. So I was not the easiest guy. And that thing was very nice. We were able to do this, Sabji and I, at was 20 megabit per second. It was 50 nanoseconds. It was really, really fast for those days. It was fast as hell. And it was working very, very well. So that's to me it was a very interesting and challenging project.
So this became incorporated into a standard product?
They ended up not incorporating it, but I'll tell you the reasons why. What happened is that after I finished this, many of the people were Olivetti General Electric, Olivetti were bought by GE, and GE was changing a lot of things, and GE wanted me to move to Schenectady. And they offered me a job there. They said, you're wasted there. We want you there. I said, I'll do it. I was about to get married, or not get married yet, but I was pretty heavily involved and engaged. And so I went to my future wife and I said, I would like to go. She said, well, of course you can go, but we cannot keep a relationship at a distance. So I said, no, I'm not going to go. So I didn't go. And so I stayed. But I was a misfit in terms of the things I could do. And at this point it was becoming GE only, and I wanted really to work for Olivetti. I thought that getting Italy into computers was what I really wanted to do, and participate into that. And being part of a 350,000 people company was not as exciting, and they were right. If I wanted to do something, I had to go to the States, and this peripheral place was not going to be a great thing. They convinced me that my future would be either there or in it was connected in one possibility, or Phoenix another possibility, but the big G635 was done. Or was they couldn't feed me. So the Olivetti guys realized that, so they quickly offered me to move to Olivetti. So I moved to Olivetti. Now we are 69. And so they hired me Olivetti, and was the same people. Most of the people that worked one place, or at Olivetti General Electric, and moved to Olivetti. And the Olivetti was interesting because they had sold all the computer stuff to GE, except the computer stuff that was tied to the evolution of calculators and typing machines. So the computer stuff tied to evolution of typing machine was word processing, which was not there yet, but was moving in that direction. And the computer stuff related to calculators was this Programma 101 that you have there, and some different way of doing computation. And the engineer Perotto was the guy in charge of this, and a couple of people, Desandre and Mercurio came to the States and unfortunately got into incredibly health issue, unbelievable.
You got an incredibly what?
Health issues.
Oh, health issues.
Malpractice.
Okay.
Malpractice, and he is a vegetable, still there. He only recognizes his daughter and Mario Mazzola. That's it. Doesn't recognize anybody else. And was my best friend and boss, and good friend and boss. And so I went to work for Olivetti. But Olivetti was thinking of doing something bigger than just the calculators machines under the same boss and umbrella of the calculator machines. And so we were trying to do these new developments. Was called the E900. The E900 or E900 was really a mini computer. And was targeted to compete with 36020 or the 36025. And was a great product, TTL design. It was very, very, very nice machines. Had magnetic media, printers. Olivetti was very strong in printers those days. And so they put me on this project. The beauty of this project, I did not go there asking for that, but happened to be downtown Milan, 1 mile from my house, where I was living now, and I was married. 1 mile from my house. It was fantastic, absolutely fantastic. And was 17 people in this apartment, downtown Milan, 3rd floor of the apartment, Via Campere. And it was unbelievable powerhouse, brain-wise, unbelievable. And we were designing this E900, and they put me in charge of designing the communication. So I was in charge of doing the communication protocol, again, serial stuff, communication protocol for asynchronous and communication protocol BiSync. BiSync at the time was 8-bit, 7-bit, and 6-bit. It was 8 for IBM, 6 for CDC, I think 7 for board, if I remember. But it was this protocol, and I designed the board to control that protocol. And I designed the board in a way that was flexible enough to control the entire thing. So asynchronous, synchronous, all the different variations, BiSync, etc., etc., etc. And was a great experience. And I remember I designed it, and a lot of the code I was writing on a PDP 11 with the 4K memory, or PDP-8 was. PDP-8 and PDP-11. So that was what I was doing. And then, so tell me if it's too much detail. And then
raise it up a little bit, yeah.
Yeah, so I did that design, I finished that design, and then that project was cancelled, and they asked us to do a more advanced project. This time it was going to be based on a new CPU, and the CPU was going to be fundamentally LSI. And so they decided that I would stop doing any protocol and any BiSync, and I would move into designing CPUs. So next thing I designed this CPU called I did two designs, 1008, 1016, and one 8-bit, one 16-bit, and they asked me to do something that was kind of a mix of the two, which I called 1009, and in the middle, and that was the CPU that was designed, which ended up as the CPU in all the Olivetti developments from then on, and was very interesting because that CPU ended up in all the banking terminals that Olivetti did. Olivetti ended up with probably 90% of the banking terminal business in Europe, and a large percentage of banking terminal business is here. Also ended up in all the Olivetti more advanced calculating machines. I'm talking now about the P6060 and those guys, big machines.
Now, were some of these computers that you were working on, or your group was working on, outside of what Olivetti technically had,
Never done it before.
Had agreed to, but they had agreed to spin off all of the non-calculator computing.
But they were not forbidden from moving in that direction. So they tried to move bottom up instead of going against IBM. And when we position them as against, in the business that we were strong in, IBM just wasn't there. They could not compete. So the entire thing moved in that direction. And I had, at this point, they decided to move us to Ivrea. We were 70 people. They took the 70 people from Milan, they moved them to Ivrea. And I ended up in charge of a big team doing CPU designs, memory controllers, all this stuff. And next to the people doing disk controllers and some of them communication controllers, there was Mario Mazzola next to head to head. And Cafiero, I think, was working either for him or for me, I don't remember. We were very close because we started commuting from Milan to Ivrea every day. So we were in the same car, the three of us. And the interesting thing is that that really took off because I designed the CPU when I was in Milan. I'll tell you this very quickly. That was the time when, we're talking now about 69, it was a very, very tough time politically in Italy. The Red Brigades were it. There was a lot of strikes. The only way I could go to work in the morning was to go to work before the picketing people would come there. They would come there at 7, I would go to work at 6. And leave after the picketing guys would leave. It was about 10 o'clock. So that was my time. And I had told them that we could do that product in 1008 chips, MSI LSI position chips. It was one board and 2 lines. And I told them I would deliver it, if I remember, was in 70 February. 70 February. And I did exactly that. And then they said, okay, done. You guys move.
So how many chips did you say?
It was 108 chips.
108.
Yeah, it was 90 on one board and 2 lines on another board. They make 18 chips. And because I had some memory that I had to put in. And it was a completely micro-coded machine. It was a very interesting machine. We'll talk about it in a second. So people really were excited about what we had been able to accomplish with that team. We developed that. We tried to develop that and then move it get the CAD department to do the PCB. It was too dense, too complicated. They couldn't do it. They would do it in 4 boards. I said, absolutely no way. Well, it's going to take us 6 months to do it on 2 boards. I said, I cannot do that. I need to deliver by February. And then it cannot be done. I said, okay, well, so I decided instead to put it on 2 boards, I said, well, we're going to be debugging this thing anyway for a long time, aren't we? Oh, yeah. So what do we need on 2 boards? We put on 1 board that is extra large. So we put everything on 1 extra large board. I did 50 of those. We put them in. And that's how we work in parallel with the guys putting on 2 boards at PCB. And the diagnostic guy said, we cannot do diagnostic for this thing. We don't have the right people. If we do, It's going to take 6 months, and forget it. We need to do the right. So I did the diagnostic myself. Then the entire thing ended up, the team would take every single thing, and we ended up doing the entire job. And that really kind of really struck people, because it was, we delivered everything we promised, and we were there, and the machine came out, the product was unbelievably successful. And then I was modifying these projects for the scientific calculator, as it was called, this 6060, for a guy that was working there that I happened to meet a few weeks ago in Milan, a few months ago in Milan. Wow, that was an experience. I never saw a 6-year-old guy cry when he met me. So, wow, it's unbelievable. And interesting enough, we did that, and now they decided that we get in charge of all processors at Olivetti and all peripherals. That was a big job, because it meant to take also responsibility for a project that was a microprocessor that I had not designed. It was designed by somebody else, but would end up in my organization, and future strategy would be depending on me. On strategy, they always ask me to do the strategy, always. There was no, and I said, well, you know, I don't know, there are processors coming from the States. So I said, why don't you do this? We need better position with the States. So why don't you find a way to go there and talk to the various companies? Lots of people have worked with the States. The people doing the Micro 8, this product, were working with, at the time, with Motorola, who was the designer of this product. And we were working very closely with Fairchild for some of the ROMs that I was using, P-ROMs I was using were closer to monolith memories, and various other companies. So I said, well, P-ROMs was the characteristic of monolith memories, you remember that, and you remember that. And so they said, why don't you do this? Your English is not that good, but you can probably make it work. Why don't you do a design based on which you can gauge the technical ability of the various US companies? And go there with this design. We'll set contacts for you with the various companies. You go there and say, would you be interested in doing this? Now keep in mind, Olivetti at this point was one of the top 3 users of integrated circuits. NCR and Olivetti were absolutely top 2. We were the largest volumes, huge volumes for those days, huge. So I said, oh, yeah, I'll write it. So I wrote it. A technical guy gave me the spec that is in my office. I'll find it one day. And I took that, and we went around. So we went to, and this was a very interesting thing, because was the CPU I designed. CPU I designed is interesting. Mario Mazzola was hired from his previous job there. And I remember that my job was to teach these people what a CPU is, how it works. And the way I did the class is taking the schematics of my CPU and go through it. Why do I need to do anything? I go through it, you realize what it is, how it's done. And I remember Mario Mazzola said, wow, that is a messy thing. Why did you do that? I said, well, thank you for saying that. That's for compatibility with the previous product. It was the only messy thing. And it was the first time Mario Mazzola heard about computers. So I always remind him that. So I came to the States, and my CPU was designed in a way that was incredibly modular, and had a control ROM, a timing ROM, and a little verification ROM. So it was completely microcoded. So you had the control word here, you had the enabling word on the timing ROM, and you had the clocking word on the VROM. Even the clock
was programmable.
So the duration of the instruction was functional of how many bits were in the clock in the shift register. That's why I destroyed the delay line. Because the delay line will give you a fixed thing, and I didn't want a fixed thing. Because then every instruction has to be the entire, some instructions are very fast, and I only just want clock. So why should I waste time? So I optimized it that way. And I applied for patents on that. I thought I was going to get 1 million patents. Unfortunately, IBM had most of the patents, but I did get a few patents, so specific on that design. Still.
So you were going to the U.S. to get them to do a microprocessor?
No, I go to the U.S. to get them to. I had to gauge their technical ability to become a partner with Olivetti. Whether it would be to do a microprocessor, to modify a microprocessor, do other things, we're not decided yet. But who were the companies with the best technical abilities? And it was a good way to look at these companies, we thought. Probably was not. But at the same time, Motorola had destroyed all their activity on bipolar for custom, so they would not do this. This product ended up being transferred to Mostek and was done, Micro 8 became the Mostek thing. So even the microprocessor was going to be probably discontinued because we did not want really to continue with that one. We're going to go with different things, probably compatible with what we had, or different products than the Micro 8 was different than what we wanted to do. So, but we noticed that Intel had designed the 8080. We didn't like the 8080 because it was a very, very unique design. There was many things you could not really design a processor there. There was no interrupt, no saving of register on interrupt. That means you had to replicate the register. That doesn't work. But they have done the 8080. They were talking about the 8080 to us because we were good customers of them too. And we like the 8080. So the 8080 looks pretty good. Now we're talking about 72, 73, so maybe 74. And maybe 74. So we went there, and the product that I had was my CPU, patented, divided in 4. It was a 4-bit slice of the CPU. So with this thing, we went with the control ROM, etc. We went to Intel and we said, "Do you think this is feasible?" And they looked at, "Yeah, do that. 2 bits is what you want to do. That 4 bits is too much." Whoa, excuse me. We went to Fairchild and said, "No, we don't want to do those things." So we went to TI. They said, "Well, we're doing the same thing ourselves." Went around. At the end, we went to Monolith Memories, and Joe McDowell was the technical guy there, and Zev Drori was the CEO. Joe looked and said, "You know what? I like it." He said, "I will do a couple of changes. You have scratch pads, 3101 Intel scratch pads. Those are we cannot do those, and it's not. We do a dual port memory. But other than that, we like it. We send you back a proposal." They sent back the proposal, and that was the first bit slice. It was the 6700-bit slice. And we became customers of bit slice, small kind. But but at this point, I was involved here. I had good connection with MMI. I had a good connection with Fairchild because some activity was also with Fairchild. So they asked me, and I talked to Intel, and I liked the 8080 very much. And I liked the fact that we're moving probably to the 85, but I think the 85 was already in the works. But I thought the 85 was. I thought the 85 was a real good product, and we should discontinue the Micro 8. So I told my friends, I said, they're investing incredibly. We cannot compete. So let's not do the microprocessor. On the other side, for our products, having a processor is not the center of everything. It's the center, but it's not really reducing the cost. We need to have all the kits around. So we really need to have a set of products that will allow us to be the best at reducing the cost of the machines that we have. So I said, okay, let's do that. So by now I'd been back and forth with Intel. Intel had offered me a job, not yet, back and forth. And they said, okay, go to Intel and see if you can convince Intel to do some peripherals. So I went to Intel, and Bob Noyce was the guy in charge of the interface with Olivetti, so I was very close in interaction with him. And Tom Lawrence was the sales guy. And I talked to several people. Glenn Louis was one guy. Stein was there, but he was a kid. He was just out of school. Talked to a few people, and we started talking about whether it would make sense for Intel to do peripheral products. And we thought it would make sense for Intel to do 3 products: a disk controller, an SDLC controller, of course, evolution of BiSync, and a CRT controller, character-based CRT controller. And Intel said, yeah, we can do it. We are willing to do it because the volume of Olivetti was huge. But there is one condition. that you discontinue your macro 8 and you give us order on 88. 88 is the standard with 88 and 885 will be the standards within Olivetti. You say, okay, we switch. All our products will be 88 or 885. And I said, great. Second condition, we're going to do it, but you will give us the expertise. And Olivetti said, okay, what do you mean? I said, the guy. So at that time, I went back and I convinced my wife by now that it would be a great opportunity. She would be moving here too, blah, 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 et cetera, et cetera, et cetera. And she was not very happy, but I did not read it well. And unfortunately, I did not read it well. And so I decided I would move to the States for a few months. Mm-hmm. And I would work on writing the specs of these things. So I came to the States, and the three products, I started writing the specs. The three products became the 8271, 73, and 75. And the guy that worked on this thing was Steve Bisset. Steve Bisset became the founder of Megatest. Mm-hmm. The guy was sharp as a tack, great guy. He looked at the first two products. He looked at the disk controller and the SDLC controller, and the way I was designing them, and he said, this product is one product. It's the same. Because the way I was designing was, I put a byte processor to process the bytes, and the bit processor to process the bits. So after I put the bits in a shift rate, I'm going to do, so that was the way, too much detail. So, but at that point it became one product, with the only difference was the shift register would be opposite, because one is first, highest bit first, the other is lowest bit first. So we had to, otherwise it would be absolutely identical silicon. Those were the first two products. And then we did the 75 that came out. When things were moving that way, I kept going back and forth from Italy. And to be understood, that is the best demonstration of my financial stupidity, because I was working now at Intel, paid by Olivetti. My salary was 1/3 the salary of a new guy at Intel, and I had no stock. So at a certain point, Intel said, why don't you join us? And I said, well, that's a good question. Okay, I will resign and join you, but I have, in Italy, you have an obligation, if you resign, to give a notice of 6 months, given my position, the 6-month notice. And so I'll join you in 6 months. So I left, I went back to Italy for 6 months. And at this point it became clear that my wife would not. Not clear yet. Not clear yet. Anyway, and then I stayed there for 6 months. Everybody knew that I was going to be leaving, and without I gave notice. And 6 months later, I sent a notice to Intel. I said, okay, I'm going to be there this week. Are you serious? Yeah, I told you I was going to be there that week.
They've forgotten about you, huh?
Absolutely. Wow. Whoa. We'll see what we'll. Okay. So I remember we sent him a telex, and they sent back a telex. So, okay, yeah, we committed. Okay, come on. So I joined them, and so I.
What year was this?
By now, we're talking about the joining was in 77. October 11, 77 was my one-way ticket.
It was your what?
One-way ticket.
Oh.
Because every other time I would come there and I had a return ticket. That was one way.
One-way ticket.
And so I got there, and turned out that they could not hire me because my visa wasn't there. So I stayed illegal for a few months, and they could not pay me either, which made it for a very interesting life. Very interesting life. And then I became legal, I think, in March, 6 months later. But in order to become legal, I applied not as an engineer, but as an artist in computer architecture. So all the ads were on art books and art magazines. Artists in computer architecture. So by now, anyway, at Intel, I got there, and the semi-5 was being finished. Unfortunately, what happened is that they had, in the 6 months that I was gone, they had decided to build another product called the 8086. And I really didn't like it. I didn't like the architecture, and I'm not going to make statements, but Intel had too much vicinity between the 86 and what became the 432. So they could not put a product too close to the 432, so they decided to position it more in the middle, and therefore they could not do a full 16-bit processor. So the entire, it's ironic, because the guy that became in charge of that product was Bill Pullman, and Bill Pullman came to Intel from designing the Western Digital DEC PDP-11 product, the whatever it was called, the Tata 11, MSC. Anyway, it's the Western Digital product that was the product done for WDC 11, it's the Western Digital Computer 11, I think. It was the one that was the PDP-11. So it was perfectly flat architecture, the architecture you wanted, everybody liked, and they were calling Intel to just finish this thing. He didn't like it either. But he made it very clear to me that that's it, ain't gonna change. We are committed to this, that's where we're gonna go. 4 segments, puking stuff. He remembers that. God. Anyway, so the 86 was done. So they said, okay, why don't you continue on the peripheral stuff? There's more stuff we want to do on the peripherals. There is more stuff we want to do on DMA controllers. There's more stuff we want to do in various areas. And I said, well, but how about the evolution of the 886? I mean, you're going to move it. I said, oh, yeah, the evolution of the 886. I said, well, I think you should move in 2 directions. One direction you push performance, the other direction you push integration. So let's move the direction of integration, we call the 186, and we'll bring in other pieces. In the direction of performance, we call the 286. And so what happened is that that was the time when I started getting heavy into the microprocessor strategy definition and decisions. And those were also the days, I may be off by weeks, but also were the days when Intel was having very difficult time financially. And very close to those days is when 79, I think, probably, is when IBM decided to invest in Intel with an option to buy more. And one of the things that IBM did those days was to ask Intel about their strategy. IBM, of course, when they asked Intel about their strategy, did not ask, tell me what your strategy is. It's IBM. So they asked, tell me what your strategy process is. And Intel said, process? Process? I mean, chips? What is your strategy process? How do you define strategy? I said, well, you tell me.
We pick a product.
Pick a product. You tell me. Oh, God. It was interesting because Gordon Moore was teaching a class on strategy. Right. Intel was you remember this was a fantastic place in terms of creating a culture. Absolutely fantastic. They would have somebody from the outside come in and teach the top manager. I'm talking about Grove, Noyce, Moore, that level. They would teach them how to hold meetings, how to decide how to hold meetings. What kind of meetings do you want and why? So they would talk about how to do these things. Then they would teach their people, reporting to them how to hold meeting, and the person that had defined that would participate in the class. And then their people would teach underneath, and the person that taught them is going to participate. So Grove will participate in my classes, and so on. So you would be sure that the message would be potentially the same. Okay, there was no internet, so you would not just go and see it. So, and that's how we propagate the culture. And I remember when Gordon Moore was talking about these things, he was teaching one of the classes, the test was given at the end, okay, define what was Intel culture when they started. What was Intel's strategy? And everybody said, well, Intel's strategy was we're going to do this, then we're going to move in processor, then we're going to do this, we're going to do that. Everybody had all these things, and everybody presented the conclusion of the class to Governor Moore and said, well, I'll tell you what it is that we had. Our transistor was smaller. We thought we could better memories. That's it.
That's it.
That's it. Now, the interesting thing is that by IBM asking that, they also advised us to use a strategy teacher from University of Chicago, I think, which was Ram Charan.
Who?
Ram Charan.
Okay,
Ram Charan came in and defined the what was called the strategic business process for Intel. Would be including a SLURP, or a strategic long-range planning, every April, and would be divided in sections. And there would be memories. There would be memories. I think EEPROM was one, and one was LSIs. And the VLSIs at the time was including peripherals and processors, and then later on became processors. And I was put in charge of the SBS processors, which is chairman of the SBS processor segment.
SBS, Strategic Business Segment?
Yeah. By the way, before joining Intel, one interesting thing for you is how did AMD ended up leading the bit slice?
Yeah, I was wondering, but I was expecting that to be the answer, and I didn't.
They called me one day when I was here, I think I was working for Intel, and they asked me, can you come to see us? I went to see them, and Clive Guest was the guy, and I tell you the name of the other guy. The guy that went to Altera, I think. Altera. And they were there, and they asked me, they said, well, you know, we really like the bit slice, monolithic memories, and we understand you know something about it. Yeah. I said, well, we don't want to second source it, we want to do our own original one. Because the military like a second source, and we would have a second source where we different monolithic memories, but they're ahead of us. So they said, if we change these things and we move, you have a multiplexer on top of the dual port memory. And you have, we put it down here, and then we take this thing and move it there, we take the registers, move it there. Do you think it still works? Yeah, it's going to work. I mean, you're going to have a slower register transfer, you're going to have faster I/O, you're going to have these other three things, but it's going to work. Great. That became the 2900. Yeah, that's it. That's exactly what happened. So,
but you were working for Intel by this time, and they were asking you?
I think was when I was working with Intel by Olivetti.
I see.
So I was here, but I was not employed at Intel. So it's so at that time I did not have an office at Intel. I had an office in the Olivetti center. Olivetti did not want me to have an office at Intel. They wanted to have total control on me. So that's and I was working on other things, including this. I was working on some stuff with the monolithic memories, some stuff with TI. So, but so Olivetti saw me as the person who can do more than just. So anyway, I went back to that because I forgot to tell you. So here is the situation. The SBS chairmanship was great. When sometimes I say I was in charge of defining the strategy. That's wrong. I was in charge of being sure that the strategy is defined. I had my job, and this was just a matrix. So I was in charge of finding out which people have a strategic mind such that you can take them out of the line job for part-time activity and define where we should go. But every single one has a job there. Nobody has a full-time strategy job. And at this point, what had happened is that Polman had left, the 286 guy had left.
Paul?
B. Polman, the guy that had designed part of the 286. And so they attached, by now we're talking about, late 70s. They attached to the strategic business segment activity and my activity in general on architectural products, the 186 and so on, they decided to put me in charge of the architecture of processors. At this point, I was my full-time job, my line job was architecture, the architectural team, and my strategy job was one I loved, was just be sure a strategy is defined. And the strategy was interesting because in order to get the strategy defined, they wanted to be sure that you had a planning committee, a product planning committee, a PPC. Product planning committee was the one who would define where the company should go. It was a 5-year plan. And was great philosophy. I mean, you will start with environmental analysis. And you say, okay, what do I do here? I need to gauge my clock. So it's a 5-year plan. So the first thing you do, you look at the world 5 years ago to just gauge what 5 years do in this industry. So you want to just gauge the clock. You want to give
figure out what the pace is. Yeah.
And then you can talk about the next 5. You might accelerate it, but not going to be crazy and not going to be stupid, thinking that what happened in a year. Okay, so that was the starting point. And then you had various things on analyzing what you did in the past, how your previous product went, doing some analysis of different segments and environmental analysis, market analysis.
And was this all part of the structure of strategic development that?
Correct. The IBM concurrence, Ram Charan setup. It was absolutely great. And I'm sure I have it on a floppy disk.
But there's nothing that will read the floppy disk.
That's exactly the problem. So, but that's I thought it was a fantastic. At the end of this, you would have a presentation that you would give to the executive of Intel on mid-April. It was the April slope. It would be a very interesting thing to do. So that was the stuff I ended up doing this, but interesting enough, the strategy was defined in a very interesting way. Because the strategy was defined as, let's not define strategy in a vacuum. And in order to do that, this person in charge of chairman of strategy is also in charge of the product operation committee. What is the product operation committee doing? Is looking at the fab and problems that we have as an operation, as a business unit with the fab. So you are always grounded. So we had the POC, Product Operation Committee, DPC, there is Product Planning Committee. And these two committees were both reporting to the chairman. So the Product Operation Committee is very important because you will learn how things really happen in the fab. So you're not going to be stupid when you do planning and think that the fab is going to do something that it's not going to do. So you need to understand what the constraints are. You remember the PPC and the POC, Planning Committee and the Operation Committee. The guy in charge of the operation committee was Paolo Tellini. No. You remember that? He was the CFO of the SBS. So we were working together with Paul continuously on this thing. So that as part of this now, I was in charge of the architecture. And what happened is that one of the things that were happening in those days was that we wanted to evolve some of the peripherals also. And we wanted to evolve some of the peripherals. And what happened is that the 72, 73, 75 was doing okay. 71 and 73 was okay. 72 and 73 were being hit by the fact that the standard changing. So the floppy disk was single density, became double density, and the other one was under IBM. So we got hit, and we had to do a second generation of those, so do the 8274 and some other stuff. And what happened is that at the same time, we were very much ahead in processors, even in microcontrollers. We had done the 48 and the 49. STAM did that. And we also had some 8061, was this 48, 49 for automotive, competing with Motorola for Ford. And the 61 had a to D converter in it that Ed Cheng designed. And we had the 8021, which is a smaller one that also had an A to D controller. NEC really liked the success of the 8080, and they had an 8080 double source themselves on a 42-pin chip with 3 different power supplies, but their processor was crap. And they wanted to, remember, they wanted to work with us on that.
They wanted to work with you on that?
Us, with Intel, and second source the Intel 8080. We ended up agreeing that they would do it on the 85, but we were really hesitant. First thing of the cooperation, we said, we really want you to understand how we are designing. So they said, well, what we really like as a starting point, we want the 8021. Oh, okay. So we went there and NEC, and at this point I was in charge of the technical interaction with NEC. And so I went there, English by now was okay, and I went there with Ken Fine. Ken Fine was the guy in charge of the operational stuff, was in charge of strategy still, and the architectural stuff. We went there and we wanted to be bold. So we told NEC, yep, we'll give you the 21, but...
Is it 8021?
8021.
What was that product?
It was a 8048 downgraded for embedded processing with the A to D converter and a few other things. I don't remember. Very, very small thing. But we said, that's done, it's ready, but we want you to design 3 chips for us. And they said, wow. So we went there, and we offered something, long story in the negotiation. Well, what a great people. Went there and and we offered something as a preliminary contract. We sent it to them. So we went there and they went in the hotel. So we called them, meeting tomorrow morning. They called us at the hotel at night and said, we saw your proposal, we're not interested. Go home. What? Yeah, we're not interested. What do you mean? No. So just start understanding what the hell, what happened. We offended them because we give you the 21, you give us 3 products. We say, well, we ask for 3 against 1, that's the problem. No. We put milestones on the 3 products under which we could just close the contract. And we did not put any milestone on the 8021. It was a finished product, we're just giving to them. So we had to go back and redraw the contract with parallel milestones. They made absolutely no sense on an existing product. We're already satisfied, but they want one parallel product on anything. And after I started understanding, I said, in this, I have to be Italian. I have to think form before I think substance. And I thought that is exactly what I did not have in Italy. That's why I wouldn't fit in Italy as well. And here is an interesting joke. I was leaving Olivetti, 6 months I was in Olivetti. I remember this guy, Ugo De Rio, comes there and says, and I wasn't saying where I was going. I had offers from everybody, from many companies, and many offers at the same time. And I don't say where I was going, but I didn't want to create any trouble. And they would call Intel and say, don't accept him, or say, we're going to close your contract, or whatever. I was going to get mad. I didn't say anything until I left. So this executive of Olivetti meets me, he's with other people, meets me in the hallway here. He says, oh, Mr. Lanza, I understand you're going to the States. I said, yes, I am. And what are we going to tell people that ask us, where is he going? Where is he going? So I will tell them the truth. And that is that you don't know. That line stayed in Olivetti for 20 years. 20 years. I was going back, everybody would repeat the line. So anyway, by now we're in NEC, we're discussing these things, and we want the NEC to do 2 products for us, for sure.
So did NEC people go back and then return?
No, we were there. We were in Tokyo.
Okay.
So we
you were in Tokyo.
You
fixed it.
Yeah, they told us go back.
Right.
So we fixed that. We started negotiating, and we were allowed to make 3 products. So the first product we wanted was the double density floppy. Mm-hmm. We did not have. The second we wanted was a product that was really making us painful. Was an equivalent to the SIO, the Zilog SIO. It was a pain in the industry. Absolutely. They buy all the kits from us and the SIO from Zilog.
From Zilog?
Yeah.
Uh-huh.
And being Fagin, they could not stand it. That was a personal thing between Andy and Fagin.
Right.
And the third product, we were going to define it. We were talking about doing various things, doing a controller for the SBC cards, and A to D controller, some stuff. So we went back with two defined, and one would define when we got back. I said, I really would like to define as a third product a graphic controller. And so I went to see Ramtech, and a couple other companies to look at the controllers. I said, yeah, that's possible. Graphic controller pretty good on this thing. So okay, let's do that. Let's do a graphic controller. And so I asked Andy whether he would let me design a graphic controller. And I think Dave House was in charge at this point by now. Yeah, Dave was in charge by now. Or even Dave House. Or Carsten, I don't remember which one. Anyway, Andy will make the decision anyway on this one. And I think it was Dave House. I remember that people said, graphics controller, it's ridiculous. A graphics controller, there is 50,000 graphics units sold every year. You do a RAM, it's ridiculous. Why do you graphics controller? Well, graphics controller is the future, blah, blah, blah. And I wasn't convincing anybody. Of course I wasn't convincing anybody. So Andy goes, I really want to do this. Well, I said, 2 for 1 is already very good. So you can do the third one any way you want it. Any way you want it. Okay, good. One condition. 5% of your time. 5% of my time. 5% of my time? I mean, 10% is 4 hours a week. This is 2 hours a week. God, how do I define a controller that is not something I know in 2 hours a week? So I don't know how to do it. So I look around who has the nicest, very compact graphics on their machine. HP had the HP 90-some. So I said, I'm going to go to the HP maintenance warehouse, warehouse HP, at the corner of Middlefield and whatever else. Daisy's on the other side. So. And I'm going to get the manual. I got the manual. I put it in an envelope. I sent it to NEC. I said, that's a spec. Do better than this. And that became the 7220 or 82720, first graphics controller, LSI graphics controller in the industry. So that was fun. It was one where people were saying, wow, how are you going to do that? But it was a very interesting experience. And some things to keep in mind at this point are microprocessors at Intel for many years, in fact, until the PC time, microprocessors at Intel were not the winner. The 8086 was not considered the winner. The 286 was considered extremely heavy and extremely not agile. Things that people don't realize, the 286 was designed inspired by Multics. So the 286 structures were inspired by Multics. When Unix was winning, Intel was so behind that we were inspired by Multics. That was the one we were really looking at. It was terrible architecture. That's where the protection came from. That's where the overhead of that architecture came from. And we're still seeing it today, still, in the terrible. You have to think about this. When I was doing the presentations of microprocessor, the microprocessor SBS, the yearly presentation, I wish Intel had still those foils, because I remember we had the microfiches, but it was the example that we give to people on how to do the SBS stuff. And I didn't. And a microprocessor, when I was talking about the microprocessor and where the microprocessor should go, I remember, I hope Andy doesn't get offended, I remember Andy Grove telling me, Lucio, you don't understand. The microprocessor is the loss leader. 2 SBS in a row is the loss leader. We make money on EEPROMs and we make money on SBC and on development systems. The microprocessor is the loss leader. Boom, that to your face at the slurp with the entire executive there and the second level, 2 levels of management. So that was Lucio presenting the microprocessor SBS. So when we talk about how great we saw it, the point is, the truth is that we knew one thing for sure. One place was absolutely positive the microprocessor would replace the existing solutions, and was the mini computers. It's the only application never went in. The only one. Went everywhere. But not that one.
And that's the only one you thought it would do,
The
right?
only one. That was positive, that one.
So much for strategy.
But at the same time, we were looking at the future. We were looking at the operating systems next to the processor. We were looking at the kernel of the operating system that was designed by, what's her name? Oh, last name is Dorr, and I remember the first name is the wife of John Dorr. She was designing Andor. And was designing the chip that would become the operating system for the 8086, the operating system kernel. So it was in his organization. At this point, he had moved. We'll talk about that. Anyway, so the point is,
Anne was at Intel as well.
Yeah, he was reporting to me, Andre, and I recall. So the interesting thing here is that so the microprocessor wasn't doing well. We will go to this West-Tech, whatever it was called, and we would get so mad because everybody was saying, were putting a sign saying 68,000 inside, and nobody would put a sign 8086 inside because they were embarrassed. So all the applications with the 86 would win. We had 1,000 design wins. Nobody cared. Absolutely nobody cared. And was just not the thing that people are excited about it. And we really were convinced, as a company, not as Lucio Lanza, but as a company, we were convinced the future was the 432, of course, for processors. And everything else was just a painful thing just before you get there. And
so Intel was not excited about the design wins. That was just not a...
They were excited more because we were design wins for the SBC, for single board computers. Mm-hmm. We were saying, yeah, it's great, but the ones with volume were very few. Tens of thousands, yeah, some. But not very few with high volume, very few that were really workstations, not one. So we really were very, very concerned about that, very concerned. And to the point that when we had, as part of strategy, and various things that were happening that we were trying to see how to win. We still consider the Z8 a big competitor in many of the business. 60,000 was talking about it, but they did not have the structure around them. They did not have peripheral chips. They did not have development system. And they did not have all the stuff they Intel had. They did not have the operating system. They just didn't have it. And they did not have the CPM86, so lots of stuff they did not have. Mm-hmm. So yeah, it was a pain. We could see strategically it was a pain, but the real pain in the neck was Zilog, was also for political reasons. So what was happening, one day I remember that Gordon Moore called a meeting in his office on Seneca 1 and said, you know what, why is the 8088 not flying? I want the 8088 to win against the 80. I say, well, it's difficult. It's big chip. It's Jack Caston was there, and a couple other people. I mean, Jack and Gordon, for reasons you realize soon. And he says, and Jack Caston says, Gordon, you don't understand. And that's the wrong start. Gordon, you don't understand.
You don't say that to Gordon Moore, right?
Don't understand. The chip is big. It's bigger than the 86 because we had to multiplex things. So even though it looks small, it's bigger. And slower because we had multiplex delay. So it's a bigger chip. I said, well, I want it to win. What if we price it down? We price it below the Z80. Let me tell you again, it's bigger than the 86. Costs more than the 86. And Gordon Wood, the only time in my life I saw him doing this, got red in the face, lifted his fist, both fists, started pounding the table. I said, price. I didn't say cost. What if we sell it for $10, $5, $1? Price, not cost. Price. Silence. Oh, price. Yeah. Oh, you can do that. So, a week or two later, we came out with an ad on electronic design. I wish we had that. The ad said, we are offering free kits for design of the 8088, and the price is $10, if I remember, of the 8088. But the tongue-in-cheek was, given the volume of the 8088, we can afford this price, which was a true statement.
It was so low that it didn't matter.
I'm not going to tell you who came up with the sentence, but the sentence was there. Remember that? Given the volume, we can afford to sell at this price. So the interesting thing is that 8088 is the one that was noticed in Boca Raton by the word processing people, the one I competed with from Olivetti, because another application of my CPU was the word processing system. Mm-hmm. And they saw it and they say, wow, 8-bit, faster than that. We don't need to have a smaller cost necessarily. We command pretty high price on these machines. 8-bit bus, it's just like a Z80, just a 16-bit inside. 8-bit does not work for word processing. And I knew that from Olivetti, because if you have 8-bit, you cannot qualify different typesets. So you need at least 10 to 12. Mm-hmm. So the fact that we had 16-bit inside would allow to switch typesets to character sets. So that's how it won. And the fact that it was 8 bits and the price was so low is what told them, we're going to design with this one. Unbeknownst to us. But I'm convinced that that's the way they started the design. We would have never won any of the computer guys in IBM. Impossible, or in digital, for the reason I was saying earlier. That's how we ended up there. So it was completely, in my opinion, completely serendipitous. It was a good move to attack a product like the Z80 with the 8088 and lower the price. That's tactically, marketing-wise, strategically, whatever, competition-wise, great move. But I did not expect, and I don't think anybody at Intel expected this thing to become very important for word processing. I did not. Mm-hmm. My 1008, I told you 1008 and 2016, my 1008 was exactly designed that way. 16-bit inside, 8-bit output. But and the word processing guys really liked it, but I did not think about that. I could take credit. I did not. Absolutely.
I thought the 1009 was the combination 8-bit, 16-bit.
Yeah, but the 8 was pure 8 bits. Okay. Pure 8 bits. And the 16 had a lot of more register than the 8. The 8 was really cut it down as much as you can. But you still had the 16-bit inside. Okay. But you will see outside an 8, and you would have a lot of lower characteristics because it had to be to real low end. That was going probably to the replacement of the calculating machines. But they could not do 2. And the 9 became the one that had the best combination of the 2. Mm-hmm. Also, the 9 became the one with compatibility with the past. And the 9 was also for another reason. 1009 reads 1009 in this way, and there is 901 in this way. The previous product was a 900. So it was called the Novecento, D900. So everybody will see in Olivetti there was the 900 first revision of 1000 2008 and 2016. So that's why I use that now. So anyway, that's how, at the end, how that PC product came about.
So how long did it take you before you realized what a good strategy this was to reprice the 8000, the 8088 to?
In that meeting. The meeting was done. The meeting, we thought about it. And
no, but I mean, once it was repriced, how long did you take before you realized how good of idea that was?
I think we left the meeting and we knew was the right thing to do. We just could not force Intel to lose money.
Right.
We didn't even think about it that way.
Right.
And Gordon can. But we knew that doing that would have given us a lot of additional products and additional wins. Mm-hmm. We did not expect the big ones, but it was going to be, we will lose to the Z80 because it had more register than the 8080 and was cleaner than the 8085. It was a better design, period. And the 8088 was reasonably superior. And the Z8000 was not taking off anyway. Mm-hmm. And that was the one they were pushing more than anything else. So anyway, so that gets you to there. The thing that we can cover next time, and we can go through that quickly, 7 or 8 minutes, is why, once we started having the 186 and the 286, what was happening and where we'll be going. Now, 186 and 286, the 286 is there, is not yet the product for the PC yet. It was the first one will come on the 8088, but it was clear that they would not look at the 86 per se, they would look at the 286 as the next big product. Even at this point, in Intel, the best pedigree architects would not endorse the 286. They thought it was a crappy architecture, was a terrible thing, was the wrong thing to do, and they started 2 different architectures. One was the 432, which we knew by now was called P5, and the other was the evolution of 432. And the other was an architecture that Glenn Miles from IBM, architect from IBM, was pushing, was called the P7. P4 and P7. And there was a tag that was an interesting architecture, but I wasn't particularly excited. But I was not in favor of changing architecture to begin with, because one thing that Jeff was referring to when I was saying I was going out as marketing guy. I was going out as marketing guy to talk about the future of the architecture, and I was in charge most of the time to talk about the entire system. Mm-hmm. So there is the CPU, but you also have the peripherals, and Dale House will be talking about the SPC, or Judy Ross will do that, or we had different teams who go around. Mm-hmm. And as Dale House used to say, he was laughing, saying that it's unbelievable how effective you are, Lucio, in presenting. People are always listening to you a lot. You're very lucky because you have such an incredibly terrible accent that nobody can understand you. So the only way to understand
listen carefully.
is to listen carefully. You're a lucky man. So by now, however, the 286 was something that people didn't like. The 2 competing architectures were that. And I remember, by now, I really thought that we had to do the 386. I was in the processor still, in the processor group. And I really thought we had to do the 386. We had to clean up our act, probably drop some of the protection stuff on the 286, try to clean it up. I also had advice from some people at Berkeley, which are the ones that were doing the flat architecture, so the ones who are doing the how do you call it? Risk machines. Mm-hmm. Yeah, I'll give you the names. So they came there as consultants, because one of the people that we had hired in the architectural team by now, Scott Furr, was one of his students, and Scott Furr was there to just try to make a sense of the next family kid in the 86 family. And it was him, Bob Childs, which was the architecture of the 286, Jack Lebanoff was working for Childs, and Steve Redfield, ex-DG, Director General. These 4 guys were now in the 86 area. Everybody else was excited at P7 or in Oregon with P4, so were the 4 of us. Because when I said I want to do the 386, they said, okay, we'll give you these people. 2 were the 286 guys and were in disgrace because of political reasons. 1 was on corrective action. So they gave me 4 people, 2 of them on corrective action. And forget it. It's, anyway, so that was my team for the 386. And then Ken Fine was put in charge of the processors. He basically told me that 386 was a piece of crap. And he did not think we should work on that, blah, 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 blah. And I happened to get a hold of a memo from one of the architects. I don't care. Glenn Myers. Memo to Gordon, this one was to Andy Grove. Andy Grove asked, tell me about this architecture, too many architecture, what should we do? So the memo was 2 pages memo, and the first 1 page and 3/4 was describing the difference between P7 and P4, both of them were incredibly good architecture.
P7, P4 again, which
432 ones? And the P7 is architecture was derived from a lot of IBM thoughts. And P7 was in Santa Clara, P4 was up in Oregon, 432. And the last sentence before the end said, and then there is the dark horse of Mr. Lanza, the 386. But I don't think we should waste time talking about that. Glenn Myers. And that's the time when I went to see Jeff Katz, and I said, I want to move to your team. He said, what did I do here? I don't care. But now he knows this is the first time I did it. So that's so now we are to the point where I'm now moving to peripherals, and we can talk about this next time. And the PC is there. So we can take it from there next time.
Okay, excellent.
Okay.